Hi, I'm Jesse Bentley with Fire Control based in Wheeling, Illinois. We are the original installers of the water-based fire protection throughout the facility here in Hebron. This video will cover an overview of the systems installed in the building, the locations of these systems, and the water supply and other general information. We will cover in detail the normal operation and principle of each system type, along with emergency procedures and normal system maintenance as required by NFPA 25. This video contains chapter markers to allow you to jump to any section as desired. This building is protected throughout with automatic fire sprinkler systems. These systems are designed and installed in accordance with NFPA 13, factory mutual data sheets, and all state and local codes and standards. The systems are supplied with water from the retention pond located immediately to the south of the building. Water from the pond is pumped with an electric vertical shaft fire pump located in the small building adjacent to the pond and accessible at the parking lot level. Inside this building you will find the fire pump and controller, jockey pump and controller, and other valves and support equipment. At the bottom of the pump is a strainer screen and an anti-vortex plate to prevent air and debris from entering the pump. The sump is fed with water from the pond through a 12-inch concrete pipe and is fitted with dual debris screens at the entry to the pump. The fire pump is rated to adequately provide water to supply the various sprinkler systems in the building. It is piped underground to a point that enters the main building. Here, it transitions to an overhead feed main that supplies two valve rooms located on the shipping dock. In these rooms, systems are provided that protect the loading dock, the VNA and ASRS freezer rooms. Also located at the entrance to the water supply into the building is one wet pipe sprinkler riser that feeds sprinklers in the offices and maintenance areas. Water supply. As mentioned earlier, water is supplied to the fire protection systems from the retention pond located at the south end of the property and is pumped into the building. This pond was developed with the normal water level being at the normal water table level in the area and should always be at an elevation slightly lower than the overflow scuppers. This provides an effective water supply of well in excess of 2 million gallons available to the sprinkler systems, which is several times the duration requirements of the codes and standards. From the pond, there's a concrete pipe connected to a sump pit inside the pump building, where the pickup from the vertical fire pump is located. At the entry of the feed pipe to the sump is an assembly of filtering screens designed to keep debris out of the sump. This assembly consists of two screens in frames that slide vertically along the sump wall in a dual track, one for each screen, and the screens are connected from above with chains whose purpose is removing and reinstalling the screens. The entire assembly is made from stainless steel and should service the facility for many, many years to come. The filter screens must be kept free of any debris to avoid blockage of water flow into the sump, and they should be checked and cleaned monthly or more frequently as required. At any point in time, one of the screens must be in the lowered position, with one screen in the sump. The other should be cleaned and kept ready for the next cycle, when the cleaned screen would be lowered first and the opposite screen then be extracted. The fire pump and jockey pump require weekly, monthly, quarterly, and annual checks, tests, and inspection. This is all set forth by NFPA 25 and will be part of regularly scheduled maintenance. On the outside of the pump building, there are several connections of different types. These are for testing and fire department use. The jockey pump and the fire pump are all configured for automatic operation. While the fire pump will only operate in the event of testing or a fire, the jockey pump's purpose is to maintain pressure in the mains from the pump to the valve assemblies. This pump should not normally run, but it is in place to maintain system pressure in the event of any leakage in the underground pipe, if a check valve should develop a leak, or to bring the system up to pressure following any system maintenance that requires shutdown of a system. Should the jockey pump be found to run frequently, the source of the water loss should be investigated. Wet pipe sprinkler system. The wet pipe sprinkler system is just that. The piping in the system is always full of water under pressure. This facility has only one wet pipe system that protects the offices and maintenance areas. The riser for this system is located in the maintenance room. The riser for this system is the simplest type, consisting of a main control valve, a combination main drain inspector's test valve, and a water flow switch to sense water movement in the pipe. The combination main drain inspector's test valve serves two functions, like the name states. By turning the handle in one direction, it operates as the system main drain and rapidly drains the system. Turning the handle in the other direction allows water to flow through a specifically sized orifice to simulate a single sprinkler head being open, which tests the operation of the flow switch and alarm system. In the event of a fire, do not close the main drain valve, but rather leave that for the fire department personnel to close only when the fire is under control. If there is some other reason for water discharge from the system not due to fire, immediately close the main control valve and fully open the main drain valve to stop the flow of water and empty the system as quickly as possible. Dry pipe sprinkler systems. There are two dry pipe systems in the building that protect the loading dock and mezzanine areas. These areas are intended to be maintained as coolers and above freezing temperatures. These are the simplest form of dry pipe system and are used in cooler spaces as they are more cost effective than the types used in the freezers. They are able to be full flood trip tested for annual inspections. Here's a short animation demonstrating the operation of these valves.
The Tyco DPV1 dry pipe valve is designed to protect areas exposed to freezing temperatures, such as unheated warehouses, loading docks, parking garages, store windows, and attic spaces where a water-filled system cannot be utilized. The DPV1 is a differential valve engineered to automatically control the flow of water into dry pipe fire protection sprinkler systems upon operation of one or more automatic sprinklers. The unique offset clapper design is the heart of the system. The simple valve design provides greater dependability. In the ready position, air pressure in the system holds the clapper closed against the water supply pressure. When a sprinkler opens due to a fire, the pressurized air in the system is released. This allows the water to open the clapper and travel to the open sprinkler to suppress the fire. Once the fire is extinguished, the external reset simplifies maintenance.
As with the wet pipe system and all other systems in the building, in the case of a fire, allow the fire department to operate these systems as required only after the fire is under control. If, however, a system is actuated accidentally due to air pressure loss, then closing the main control valve and opening the main drain valve will, like the wet system, stop the flow and empty the remaining water from the system. Double interlocked dry pre-action system. As mentioned, all of the freezer spaces are protected with dry double interlock pre-action systems. Here's a short video demonstrating the operation of the valve assembly.
The DV5A double interlock pre-action system is designed for use in applications such as refrigerated areas requiring the maximum degree of protection against inadvertent flooding from the sprinkler system piping. The heart of the system is the DV5A deluge valve. When a fire is detected, the system opens the deluge valve, allowing water to travel to the automatic sprinklers to suppress the fire. The DV5A's single moving part simplifies maintenance and provides dependable performance. The integrated alarm port provides a compact design. No additional check valve on top of the valve is needed. The DV5A is part of Tyco's compact trim package, specifically designed for easy installation, access, and maintenance. The other key components of the actuation system are the electric fire detectors, the automatic sprinklers, the control panel, the dry pilot actuator, and the solenoid valve. Let's look at the system in operation. In the ready position, the sprinkler pipes contain compressed air, while water pressure in the DV5A diaphragm chamber holds the valve closed against the water supply pressure. The double interlock requires two events to occur for the system to discharge during a fire. First, the electric detection system senses smoke, signaling the solenoid valve to open. Second, the automatic sprinkler heads will burst due to heat. The loss in air pressure opens the dry pilot actuator, releasing water from the diaphragm chamber. The higher pressure from the main water supply pushes the diaphragm open, activating the alarm, allowing water to flow to the sprinklers and suppressing the fire. Tyco also offers a double interlock electric-electric option, which combines heat detection with a low air pressure switch to activate the system.
Each system consists of the pre-action valve itself, together with a releasing panel, a network of linear heat detection located at each sprinkler location, a pressure switch, and various other parts on the valve trim. Each system also has a main control valve and an additional valve located above the pre-action assembly. This second control valve is provided so that the pre-action valve assembly can be operationally tested without filling the system piping in the freezer. Each valve is provided with its own releasing panel. This is a controller that is connected to an array of heat detection in the freezers, as well as to a fancy pressure switch located on the valve assembly and a solenoid valve also located on the valve assembly. The video demonstrates two different actuation types, but we are only concerned with electric actuation here, as that's what's installed in the building. As mentioned, there are two independent signals required to actuate the valve and allow water to enter the system piping, one being a heat detection signal and the other being a rapid loss of air pressure in the piping equal to a sprinkler head opening. The releasing panel monitors the heat detection and the pressure switch, and when both signals are present, it powers the solenoid valve located on the valve assembly, which then allows water flow. This provides a high degree of safety from an accidental water discharge, while assuring that in the case of an actual fire, the valve actuates so the system can do its job. The heat detection is provided by an array of linear heat sensing cables strung along the length of all the sprinkler piping. This wire consists of two conductors within the cable and separated by a heat-sensitive polymer insulation. If heated anywhere along its length, the insulation causes an increased resistance in the wire, which the releasing panel interprets as a fire signal. The other signal is provided by the pressure switch located on the valve assembly. This component, called a QRS or quick release switch, is a sophisticated device that samples the air pressure many times per second. If there's a rapid decrease in system pressure, as if a sprinkler head is opened, the switch sends a specific signal interpreted as trouble to the releasing panel, which together with a heat detection signal will operate the valve. If there is a slow decrease or increase in system pressure, which would be the case if there were a problem with the air supply, the switch sends a supervisory signal to the releasing panel, which then alerts to the supervisory condition. The switch also has a fail-safe mode. In the event that system air pressure drops to zero, as would be the case if the low pressure supervisory alert were ignored, it then sends the trouble signal to the releasing panel. This will not actuate the valve, but rather arm the valve, so that if the releasing panel receives the heat detection signal, it will then open. In this condition, the valve is only one condition away from releasing, so don't ignore anything beeping in the releasing panel or the building fire alarm panels. Other components on the valve trim assembly include a manual release and pressure alarm switch. Operating the manual release will override the entire releasing mechanism and open the valve. This function, of course, is reserved for emergency situations and should be used if there is indeed a fire and the normal releasing system has failed, or if a fire is confirmed and the releasing system simply hasn't operated yet. The manual release is entirely mechanical and will work regardless of building or releasing panel power failure. The releasing panel contains backup batteries that, in the case of a power interruption, will ensure normal system operation. The last item on the trim that I want to mention is a pressure alarm switch. This switch will send an alarm signal to the building fire alarm panel if a system is manually activated and in the case of normal operation is redundant to other releasing panel alarm functions. All of the pre-action systems in the building are designed to operate with air pressure of 60 psi. The QRS switch is configured to expect this pressure and will send the supervisory signal if the air pressure goes 5 pounds above or below that point. In the event of an accidental discharge of water into the system, immediately close the lower main control valve and open the main drain valve to drain whatever water you can. If, as is the case for the other system types, there's an actual fire, leave system shutdown to the responding fire department after the fire is contained. And finally, we've provided a piping corrosion prevention device that is located in the air supply piping where it is connected to the automation air supply. This device can be found in the machine room on the mezzanine second floor along the north wall. This system provides a molecular level coating inside the sprinkler piping. The system is relatively maintenance-free other than the requirement of replacing 3 powder supply canisters on the device at each annual inspection.
Introducing a game-changing innovation in corrosion control technology for the fire sprinkler industry. Vapor Pipe Shield from General Air Products is a patented, UL-listed vapor phase corrosion inhibitor delivery system that is fully mechanical and pipes directly in line, making corrosion mitigation in any dry or pre-action fire sprinkler system efficient, easy to install and maintain, and highly cost-effective. As simple as installing an air maintenance device, Vapor Pipe Shield, made up of a canister and filters, is a completely mechanical install hooked up to your existing piping with no electrical connections. Once Vapor Pipe Shield has been installed, the corrosion-inhibiting vapor will be carried by the airflow provided by the sprinkler system's supervisory air compressor. Using a technology backed by over 40 years of established science, as the vapor phase corrosion inhibitor, or VPCI, travels through the piping network, an electrical charge attracts and bonds these molecules to the metal surface and never to each other, creating a 1-molecule thick barrier and forming an invisible protective shield. This VPCI shield prohibits any and all water or chlorides from contacting the pipe directly, stopping corrosion in its tracks. The vapor created by Vapor Pipe Shield moves quickly and efficiently through your entire system, bonding with any available metal surface, ensuring a continuous barrier. The VPCI molecules are also water-soluble, penetrating standing water and protecting any pipe beneath it. The vapor even continues to migrate downstream and bind to the pipe when the compressor isn't running, making Vapor Pipe Shield the first and only active corrosion control system for dry and pre-action sprinkler systems. Vapor phase corrosion inhibitor has been a proven industrial technology for decades. The only reason it hasn't been introduced to dry and pre-action fire sprinkler systems is that no one had invented the right delivery method. Until now. With the patented UL-listed Vapor Pipe Shield, General Air Products is proud to bring the most effective means of corrosion control worldwide to the fire sprinkler industry.
All of the systems in the building require monthly, quarterly, and annual testing and inspection. These needs are addressed in our initial inspection proposal and is beyond the scope of this video. I hope you found this video informative and more than adequate. If you have any questions, please contact us in our Wheeling offices. Go to www.f.cifp.com or call our main number at 847-459-4570. Thank you and have a great day. At the entry to the feed pipe, at the entry of the feed pipe to the sump is an assembly of filtering screens designed to keep debris out. At the entry of the At the entry of this pipe into the sump, I can't ad lib to save my ass.